All right, today's the last lesson in Unit 4, and we're going to be learning how to write a function rule or write an equation. Now, we're going to be working backwards from what we've done in previous lessons. Okay, so what I mean by that is instead of giving you the function rule and making a table, so let's like flash back to last set of notes, last lesson. In this lesson, I gave you guys the function rule, like the equation, and you had to make up the table. This is going to be the reverse of that. This time, I'm going to give you the table, and you have to write the function rule. Okay, so the goal for today is being able to write that function rule. Just the opposite of what we've been doing. Okay, we keep it very basic. There's no like absolute value or squareds, but you still have to kind of like use your brain and notice patterns. So in the following tables, and that's all this front side is, you need to do exactly what I just said. You have to identify the pattern that gets you from the x value to the corresponding y value. Once you've figured out that pattern, you can write the function rule. Okay, so here's what I mean. Notice that f of x and y are going to be used interchangeably. They could use either one. It means the same thing. I have to figure out, though, so I can write the function rule, how do I get from the x to the y? And you do ones that correspond with one another. So like 0 and 3 go together. 2 and 5 go together. 4 and 7, okay? You got to figure out how are these two things related. What am I doing to the x to get the y? So here's what I do. I just look at one row at a time, and I start at the top. And I think to myself, how do I go from 0 to 3? Think basic, you guys. Think adding, subtracting, multiplying, and dividing. If it's getting bigger, I'm probably either multiplying or adding. So I think to myself, 0 times what is 3? Okay, nothing. 0 times anything is 0. So probably going to be addition. If I add 3 to 0, I would get 3. Okay, that worked there, but I have to make sure for it to be the right pattern for the function rule, it has to work all the way down the table. So I need to check that. If I add 3 to all of these x values, do I get the y value that corresponds with it? 2 plus 3 is 5, 4 plus 3 is 7, 6 plus 3 is 9. Okay, so it worked all the way down. So the pattern is I'm adding 3 to x. Once I've found the pattern, I can put it all together to write the equation. Here's what that's going to look like. They didn't use y, so I'm not going to use y. I'm going to say f of x. So to find the f of x value, I just take the x value and I add 3. So to generalize that, I would just say f of x equals x, whatever number that may be, plus 3. And that's the answer. That's the function rule. I'm done. Okay, let's do the next one. So same thing. I just look at one row at a time. 0 to 0. All that tells me is I'm either multiplying or dividing. Or adding 0, which would be stupid. But that could be it. I don't know. So 0, 0, that doesn't tell me a whole lot. Shift down to the next row. Okay, 1 to negative 4. That tells me a little bit more. So here's what would go through my mind. I'm either subtracting 5 or I'm multiplying by negative 4. I got to see which one of those works all the way down. So let's try subtracting 5. 2 minus 5. No, that's not negative 8, so it's not subtracting 5. Let's try multiplying by negative 4. 2 times negative 4 is negative 8. Negative 3 times negative 4 is positive 12. Okay, so I found the pattern. Multiplying by negative 4. So now I can write the rule that shows how the x and y are related. That's all the function rule is. Shows how the two values are related. They used y, I'm going to use y. So to get the y value, I take the x value and I multiply by negative 4. You should write that negative 4x. That's the best way to represent that. Don't use a multiplication symbol, just put the -4 in front of the x. Okay, example 3, I want you guys to do on your own. I'll check that tomorrow. I'm going to do example 4 because it's a little bit harder. So same thing, I look at each row. And this one's a tad different. Some of them are different. And I would look 0 to 15, so I'm probably going to think I'm adding 15. But notice the next one, 5 plus 15 is 20, not 10. And 10 plus 15 is 25, not 5. Okay, so that didn't work. So for me, then I would probably think, well, am I dividing? No, because sometimes it gets bigger, but sometimes it gets smaller as I go from x to y, or x to f of x. So that's kind of tricky. That's when you probably just want to take a step back and see if there's something else that you can come up with. Be a little bit creative. And some of you would see it right away, and some of you probably wouldn't. But here's what the pattern is on this one. If you do 15 minus 0, you get 15. That works all the way down the list. 15 minus 5 is 10. 15 minus 10 is 5. 15 minus 14 is 1. This one's tricky. I'll start it. Some of you are just better at patterns than others, and that's okay. Not all of them are tricky like this. But if I wanted to figure out how I represent this, and let me write the pattern. I just do 15 minus the x value. That's how I get the y value. So to represent that, I'm going to use f of x, and I'm just going to generalize it, and I say 15 minus whatever the x value is. That gives me f of x. Oh, skip the bottom. Okay, the last two questions here ask me to kind of go a little bit further with some of these. This says in problem number 4, right here, what is f of 20? Remember function notation from a couple lessons ago. That's just trying to tell me to plug in 20 for x into the function. Okay, so I'd put 20 here, but that just is the name, remember. That means I plug in 20 to the function. I just have to work out 15 minus 20, which is -5. The second part says, well, what's the x value when f of x, or the y value, is 3? So same function. If f of x equals 3, I could put that right here on the left-hand side. Keep the right-hand side the same. So instead of giving me the x value, they gave me the y value. So I just stuck that in there. Now I could just work backwards and solve this for x. So I could subtract 15. To get rid of that negative, you divide by -1, and that would make it positive 12. That was fun, huh? All right, on the back. So there's two parts to this, you guys. You're either given the table, and you have to write the function rule, or you're given a real-world situation, and you have to write the function rule. So here's the real-world situation part. First example is they're talking about frozen yogurt at Yo-Yo's. Love frozen yogurt. It's very basic of me, but that's okay. So a cup of frozen yogurt at Yo-Yo's cost 49 cents per ounce. I want to write a function rule, that's just an equation, to show how the cost, and they tell me to use C of n to represent the cost. So what's the cost of buying n ounces? Now, I'm going to make a note. If they tell you to use certain variables, you should do that. Ew, I feel like my handwriting is very sloppy, but that says use variables they tell you. So you guys can do this. We've done this before. We've just never done C of n. We'd probably always do C, but that just means the cost. So that's like the y value. To get the cost, it's 49 cents per ounce. I know per means multiply. And they told me to use n for ounces. So I'm just going to do 49 cents times n. If I multiply my ounces by 49 cents, I have how much I spent, my cost. Now they're going to ask me, hey, use your function rule to kind of work out some situations. This is very important. I want to know how much I'm going to spend here. Let's say I'm feeling very hungry and I get 8 ounces of frozen yogurt. How much do I spend? Well, I know that I just come to my function rule and I do 49 cents times the ounces. And I get 3.92. I don't know how accurate this is. I feel like in the past I've had a student who worked at Yo-Yo's and they told me how much it costs. I feel like it would cost more than this. I don't know. Maybe you guys know. Maybe you eat frozen yogurt more than I do. If you know, tell me. Part C says, how many ounces could you buy with $6? So really, they're just going to give you one of the variables. On part B, they gave me N, the ounces. Part B, they're giving me how much I spent. They're giving me the cost. So they're giving me C of N. So instead of plugging in here, I'm going to plug in here. So we got to work backwards. I spent $6. How many ounces did I buy? Plug it in. You guys know how to solve. You just divide by 0.49. Okay, so I get 12.2. Can I buy 12.2 ounces? I don't know, maybe, probably. Yeah, can you? Yeah, you can buy however many ounces you want. Let's say I do want to just, I'm feeling like I want to be even today, and I want to buy either 12 or 13. Think about how many you can afford. So let's practice a rounding problem here. Say you rounded up to 13. I don't know why you would, but say you did. Well, if you buy 13 ounces of yogurt, you spend $6.37. So I can't do that. I have to buy 12 ounces. Too bad, so sad. But you could probably get a cup of yogurt that costs that. I know you could. So either one's fine, but to practice rounding, you could only afford 12 whole ounces. Okay, I want you guys to try all three parts on problem 2. You can do that. Number 3 is the last one I'm going to do, and then unit 4 is complete. So it says, write a function rule to determine the change you would get from a $20 bill when purchasing items that cost $1.25 each. They did not tell me what variables to use. So I'm going to use whatever I want. And if you want to go back the old way and just use C for change, you can. But I'm going to use this function notation stuff because I'm really extra like that with my math. But I'm talking about how many items I purchase and how much change I get. So I'm going to use I for items. And for change, I'm going to use C of I. Okay. Change is related to how many items you buy. That's kind of all that means. The change is the Y that goes by itself. So you got to think about how to write this. This is kind of tricky, but you're going to hand the cashier a 20, and I need to figure out how much change I get if each item is $1.25. So basically, if you buy one item, to get your change, you do 20 minus $1.25. If you buy 2 items, you'd spend $3.50. So, $2.50. So if you want to figure out your change, you do 20 minus $2.50. So basically, here's how it comes together. Take 20 and subtract how much you spend, and that's how much you're going to get back in change. So they want to know, well, how much change do you receive? And you guys, the second parts to this problem always just have you use the function to calculate it. So if you buy 5 items, all I'm going to do is plug in 5 for I. I would get $13.75 back. Then the second part has me doing this in reverse. Can you purchase 17 items with a $20 bill? Oh, well, here's what I'm going to do. 17 items. Let's plug that in for I. Negative $1.25. Okay, so I obviously can't afford this. And if you wanted to check yourself, if you bought 17 things, you'd spend $21.25. You don't have that much money. So I'm going to say, no, that would cost $21.25. Too bad, so sad. I'm poor. I don't have that much money. All right, that's unit 4.